Good day. This time, let's have properties of logarithmic functions. Let's have the definition of logarithmic function. It says here, for x greater than 0 and x less than a not equal to 1, y is equal to logarithm of x to base a if and only if x is equal to a raised to y. Again, how do we read this? Logarithm of x to base a or log of x to base a. Logarithm, log is the shortcut of logarithm. Logarithm of x to base a. The function given by f of x is equal to logarithm of x to base a is called the logarithmic function with base a. So take note that a here is the base. It is the subscript. Next, so don't forget that y is equal to log of x to base a is equivalent to x is equal to a raised to y. So if you can still remember that x equals a raised to y is exponential function. Remember the lesson last time? So x equals a raised to y is exponential function. And this one is the logarithmic function or log function. Looking at these two, it is telling us that the two are inverse of each other. The inverse of logarithm is exponential function. Now, let's take a look. X here is also x here, which is the result or the number. Now, a, which is the base in logarithm, is also the base here in exponential function. So, obviously, a here is the base. And the y here, the result of logarithm, is the exponent of exponential function. Meaning to say, logarithm is also exponent. When you think of logarithm of a number, this is referring to exponent also. So logarithm and exponent are inverse, or logarithmic function is the inverse of exponential function. Let's have the following example. We have two columns here. Column 1 are exponential forms and column 2 are logarithmic forms. Let us compare 2 cubed equals 8 is the same as logarithm of 8 to base 2 is equal to 3. So here 2 is the base. In logarithm, 2 is the base here also. So base. 3 exponent, it's the exponent. So here 3 is the logarithm. And 8 is the result. So it's like 2 cubed is equal to 8. 2 cubed is equal to 8. The answer here at the right becomes the exponent. So 2 cubed is equal to 8, like here in exponential form, 2 cubed is equal to 8. Next, 1/2 raised to negative 4 is equal to 16. It's the same as log of 16 to base 1/2 is equal to negative 4. It's the same thing as when you raise 1/2 to negative 4, you will have 16. Next, 5 raised to 1 is equal to 5. In logarithm, logarithm of 5 to base 5 is equal to 1. So the same. And last, 3/4 raised to 0 is equal to 1 is the same as logarithm of 1 to base 3/4 is equal to 0. So I hope you are seeing now the comparison, the connection of the two forms, the exponential form and logarithmic form. Let's have more examples as we go on to the next slide. This time, let's have more examples. Write the equivalent exponential equation and then solve for y. Example number 1, y is equal to logarithm of 16 to base 2. Before we solve for the value of y, let us first change this to exponential equation. So y is equal to logarithm of 16 to base 2. How do we write it in exponential equation? Remember, the base is 2, so always write the base, which is 2, and then the exponent is y, this one, so 2 raised to y is equal to 16. And then solve this using your knowledge about exponential equation. So this will be 2 raised to y, change 16 to exponential form with base 2. And to make it 16, its exponent should be 4. Therefore, y is equal to 4. Y here is equal to 4. Let's find out if our answer is correct. Here it is. 16 is equal to 2 raised to y, or the other way around, it's also the same as 2 raised to y is equal to 16. And the result is the same, y is equal to 4. So 16 is equal to 2 raised to 4, y is equal to 4. Next example, but before that, let me erase the solutions here so that you can see the examples clearly. Now, example number 2, logarithm of 1/2 to base 2. So how do we solve this? Again, let us write this in exponential form. Our base is 2, so let's write 2, and the exponent is y equals 1/2. So 1/2 is the result. So this one will become 2 raised to y, and then 2, get the reciprocal, it's 2 over 1. Since there is exponent here na 1, when you bring up or when you get the reciprocal, this one will become negative. So since 2 and 2 are the same, y therefore is equal to negative 1. So y is equal to negative 1 for this example. Let's see if our answer is correct. Yes, it is. 1/2 is equal to 2 raised to y. It's the same as 2 raised to y is equal to 1/2. And for the final answer, yes, it's correct. Y is equal to negative 1. So let me erase again before we go to the next. Ayan na, the next one is y is equal to log of 16 to base 4. Again, y is equal to log of 16 to base 4. So our base here is 4. Let's write it this way. So 16 is equal to base 4 raised to y, the exponent. So let's make 16 with the base 4. So 16 is the same as 4 squared, and copy 4 raised to y. So the same for now, therefore y is equal to 2. So y is equal to 2. So let's see if our answer is correct. I can see it clearly now. So 16 is equal to 4 raised to y. Check. And it says here y is equal to 2. So the same result. And finally, the last example. The last example now. Y is equal to logarithm of 1 to base 5, or log of 1 to base 5. So let's look for the exponent of 5 for us to get 1. So this will become 1 is equal to 5 raised to y. Without solving this, for 5 to become 1, its exponent should be 0. Therefore, y is equal to 0. So let's see the answer here. So I think it's the same. Let's see, yan. Y is equal to 5 raised to y. And finally, its final answer, y is equal to 0. So the same result. I hope everything is clear. Without actually doing this part, if you know already the concept that when you do the logarithm, you also need to solve it using exponential form, and you don't like to write this anymore, looking at this, let's say log of 16 to base 2, always think that 2 is the base and y is the exponent. What exponent of 2 will give you 16? Just think, 2 raised to blank is equal to 16, and the answer is 4. That is 2 to the 4th. Next, 2 raised to blank, 2 raised to y will give 1/2. and that is negative 1. Next, 4 raised to y should give 16. 4 raised to y, what should be my exponent to 4 for me to get 16? And that's 2. And finally, 5 raised to y is equal to 1. What exponent of 5 will give me 1? And that is 0. Let's have common logarithm here. The common logarithm is called base 10. This is the usual logarithm that we always use, and the default in the calculator is always base 10. The base 10 logarithm function f of x is equal to log of x to base 10. With or without 10 here, when you see log of x and there's no number or no subscript, it is understood that this is in base 10, logarithm of x to base 10. Like square root of 10 example, for example, no need to put 2 here because understood that if you have this symbol, it's square root. The root here or the index is 2. So the same thing in logarithm, if you cannot see any subscript or the base here, understood that the base is 10. So that's logarithm of x to base 10 or log of x to base 10. So this is called common logarithmic function. So in calculator, logarithm, the symbol log there is 10. It means to base 10. So let's have examples here. We have the function value, keystrokes, and display. If you have logarithm of 1000 to base 10 or log of 1000 to base 10, when you use your calculator, if you have calculator this time, you use this, you do this, log of 1000 and enter. So press first log, then press 1000 and enter. And on the display, you will see the answer 3. Meaning to say, logarithm of 1000 to base 10 is 3. This is simply asking what is the exponent of 10, and that is 3 for you to get 1000. Next example. Logarithm of 2 over 5 to base 10. Again, this is asking what is the exponent of 10 for us to get 2 over 5. Using calculator, press log, press 2 divided by 5, then enter, and the answer that you will get is this one. It's in decimal. It's not exact. Negative 0.3979 I hope you got the same result. Next example, logarithm of 5 to base 10. This is asking us what should be the exponent of 10 for us to get 5. So using calculator again, press log, press 25, and press enter, and the result that you will get is 1.39794 and so on and so forth. So it's not exact. Next example, logarithm of negative 8 to base 10. So what should be the exponent of 10 for us to get negative 8? So using calculator again, press log, press negative 8, enter, and the result is error. Why error? Because there is no such exponent that will give you an answer of negative. Kasi logarithm of 10 is our base here. When you check for that, there is no exponent for 10 that will give us negative result. That's why it's error in the calculator. Properties of logarithm. Number 1, logarithm of 1 to base a is equal to 0. So this is true because since a is the base, when you raise it to 0, like this one, a raised to 0, the answer is really 1. Because previously you learned that any letter like a raised to 0, the answer is always 1. Any letter raised to 0 is equal to 1. Any number raised to 0 is equal to 1. So property number 1 is really valid. Next, property number 2, logarithm of a to base a is equal to 1. So what is the hint here? As long as you have the same base and the same number here, the answer is always 1. Since a raised to 1 is equal to a. So a, or a number raised to 1, is the number itself. So number 2 is valid property. Property number 3, logarithm of a raised to x to base a is equal to x. And a raised to logarithm of x to base a is equal to x. If you see like this, getting the logarithm of the same base with the base here and the same exponent x here, the answer is x. So it's the same as this one, that when you raise a to logarithm of x to base a, the result is also x. Property number 4, if logarithm of x to base a is equal to logarithm of y to base a, and then we can equate x and y. So x is equal to y. So again, if you see the same base here, and then you have equal sign, you have x and y, or any letters or numbers, as long as the same base, we can remove log and the base and just equate the two numbers or letters, x is equal to y. So these are the 4 properties of logarithm. Let's have the following examples. Logarithm of 6 to base 6 is equal to what? Again, if you have question mark here, this is referring to exponent. Since 6 is the base, what should be the exponent of 6 for us to get 6? So it's like 6 raised to y is equal to 6. So what should be the value of y here for us to get the same number 6? So of course, your y should be 1. So y is equal to 1. Next, logarithm of 3 to the 5th power to base 3. What should be the exponent of 3 for us to get 3 to the 5th? So what should be this answer? So this is 3 raised to y is equal to 3 raised to 5. So obviously, no need to compute anything. We have the same base here. Therefore, we can equate the exponent. So y is equal to 5. Y is equal to 5. And as what I mentioned when I was discussing the property, when you see the same base here and the same number here, simply copy the exponent 5. So that's why the answer here is 5. Next, logarithm of 100. So this is the common logarithm. We cannot see any base here. And as what I told you a while ago, if there is no base, understood that there is 10. So logarithm of 100 to base 10. What is the exponent here? This is referring to the exponent. What is the exponent of 10 here for you to get 100? And the result is 2. So it's like 10 raised to what exponent for you to get 100? So y therefore is equal to 2, because when you change 2 to y, so 10 squared is really 100. So y is equal to 2. So these are the examples applying the properties that we discussed a while ago. Next, let's have the natural logarithm. This time, we call it base e. A while ago, we had common logarithm, and that is base 10. This time, it's base e. Using your calculator, if you want to validate, if you will press e, the result that you will get is this 2.718281 and so on and so forth. So this is the natural logarithm with base e. So later, as we go to the next discussion of the lesson, you will encounter e, and this is very useful in solving problems involving exponential function and logarithmic function. So f of x is equal to log of x to base e is equal to ln x. Again, this is not 1, this is ln x, ln. So we have base e, we have ln, we have base 10, and so on. So introducing to you your new friends, base e, base 10, logarithm, then this time we have ln. So the same, log of x to base e is equal to ln x. X here should be greater than 0, and e is equivalent to this. Remember this, y is equal to ln x is equivalent to e raised to y is equal to x. So there is inverse again. This is the exponential function. This is the natural logarithm. Y is equal to ln x. Let's have examples. Since you have calculator, you can press everything in your calculator. So we have the function value, keystrokes, and display. Example number 1, ln 5. Using calculator, press ln, press 5, press enter, and you will get 1.6094379 and so on and so forth. Next example, see ln negative 5. Press ln negative 5, enter, and the result is error because it's negative here. It will not give any answer. That's why it's error in your calculator. Next, ln 10, press ln 10, then enter, and the result is 2.302585, and so on. So these are the examples using natural logarithm. If there are properties for common logarithms, there are also properties for natural logarithms. Property number 1, ln 1 is equal to 0 since e raised to 0 is equal to 1. Again, ln 1 is equal to 0 since e raised to 0 is equal to 1. Property number 2, ln e is equal to 1 since e raised to 1 is equal to e. Again, ln e is equal to 1 since e raised to 1 is equal to e. Number 3 property, ln e raised to x is equal to x, and e raised to ln x is equal to x. And finally, number 4, if ln x is equal to ln y, then we can remove ln and simply equate e is equal to x is equal to y. So these are the 4 properties under natural logarithms. In the next slide, we're going to apply all these properties. And all you have to do is remember that ln 1 is 0, ln e is 1, ln e raised to x is equal to x. And if ln x is equal to ln y, then x is equal to y. Let's have the following examples. All we have to do is to simplify its expression. Number 1, ln 1 over e squared is the same as ln e raised to negative 2. So the answer here is negative 2. Next, number 2, e raised to ln 20 is simply 20. Simply get 20 here when you see e raised to ln. Next, example number 3, 3 ln e is the same as 3 times 1 because ln e is equal to 1. So 3 times 1 is equal to 3. And finally, square root of ln 1 we know is 0. So therefore, the answer here is 0. So that's all about the examples under natural logarithm. That's all about the different properties of logarithm and some examples. In our next tutorial, let's have more examples about solving logarithms, applying the different properties. Thank you and God bless us all.